In this video, we're going to be covering another interview question. This question is known as optimal utilization. So, an example of this question is going to be question number 1099. So, 1099 on the Leetcode, right? But this is like you need to have the premium version in order to see that. So, but you can actually, there is a clone of your Leetcode which is known as the leetcode.ca. So you can actually see that question over there 1099. Basically, an array has been given like 1, 5, 2, and 3, and they say that the target is equal to what the target is. The target is equal to, let's say, 7. So you need to have the two numbers which are gonna add up to make 7. So the algorithm we use over there is to sort them first, and then one pointer is gonna be on the left side and another pointer is gonna be on the right side. And in linear time, after the sorting, in linear time, you can figure out if it is still less. You're gonna be uh, if it is if the current sum is less, you're gonna increment the I while keeping the j over there, and if it is more than the target, you're gonna keep the I where it was while bringing the j back. Okay, that's how you would do it, and the time complexity is gonna become O n log of n, where n are the number of elements given. We're gonna be doing another question similar to that. So in this question, the theory is gonna be the same, but it's not gonna be one array. So the question is that we have been given two lists, A and B. A is equal to, so we have, instead of one array, we have two arrays, A and B, and we're gonna have one, and let me just copy the example here. Okay, so here's the example. A is 1, 2. 1 is the ID of this element, 1, 2. Over here, 2 is the ID of this element. 3 is the ID of this element whose value is 6. In B, we have one element whose ID is 1 and whose value is 2. We're gonna return indices or IDs from the array A and array B, which is gonna, in our case, the values, in terms of the values, the value of the ID 2 is 4 plus the value of ID 1 is 2 is equal to 6. This is the closest sum to the target, right? And this is the closest one to the target, and still staying less than the target. Let's take another example here. Okay, okay, now we have this A with 4 elements and their IDs and the values. B has 4 elements with their IDs and the values. Target is equal to 10. So again, the answer, let's just write down the answer. The answer is 2 4 and 3 2, which means that look at the A's ID 2, which is this value is 5, and look at the B's ID 4, which is the value is 5, right? So that is gonna make 10. Similarly, look at the A's ID 3, the value is 7, and look at the B's ID 2, the value is 3, and that's gonna add up to the target. Okay, in terms of the algorithm, just like this question, we're gonna be sorting A and B based on the values, right? And then we're gonna have 2 pointers. So in this case, the sorted is gonna be the same value. Over here, the sorted is gonna be the same value. So both of them are already sorted by their values. So our I is gonna be here, right? And our J is gonna be here. We're gonna try to add them, and then if the result is less, if the result is less, we're gonna increment the I to the next element, right? Because we want the bigger number, and we're gonna keep doing it, right? So right now the target is gonna be equal to 10 for this one. So in order to come up for the second answer, this one 3 2, right? What is gonna happen is like 3 and 5 is less. It's gonna, we already are here, right? We found the answer, but still we wanna go forward, and we wanna say 7 plus 5 is equal to 12. So we wanna bring it back. So 7 plus 4 is 11. We wanna bring it again back. So 7 plus 3 is the answer. So we wanna put it in the answer. Their IDs 3 and 2, and we wanna keep coming back. Sorry. So once after that, I is gonna go forward, right? And then we're gonna say that okay, the 10th and 3 is gonna be more, right? So we're gonna bring this back here, 12, and then this is gonna come out of it. And whenever one goes out of the range, we're gonna stop over there. So that would be it. That's what we're gonna be programming here. So let's have this public. The thing which we're gonna be returning is the list of int array and get pairs, and or you can, as the question is known as optimal utilization, just call it optimal utilization. Okay, list of int of array A, list of int array B as int target. Okay, first thing we want to do is the collections dot sort. We're gonna give it A. The way we're gonna give it a lambda function. The way we want it to sort them is compare A of 1, second element, not the first one, as those are the IDs. We're gonna do the same thing for B. Actually, exactly the same thing for B. Yes. Okay, and then list of int array. This is gonna be our result. It is equal to new array list. We're gonna do the sanity check here. The big. Actually, let's just do the int max is equal to integer dot minimum value. Let's have m equal to the A size. We're gonna have int n is equal to B size. Int I is equal to 0 and j is equal to n minus 1. As we talked about it, that the I is going to be pointing here, j is going to be pointing over there, right? While the I and j both stay within the limits, what we're gonna do is like int sum. Every time we have to do the current sum, right? Of 1 plus b dot get of j of 1. Okay, we're gonna compare that to the target. If the sum is greater than the target, all you have to do is negative negative j. Else, you're gonna do is that if the max is less than equal to sum, right? We wanna say that okay, the reason being it is that every single time, because we're not only looking for the exact numbers. So here's the trick here, because we still want to keep that okay, that the max is less than the sum, right? And what you need to do is you're going to make max equals to sum, right? And then you're going to clear the result. And the reason we are doing it is because they asked us to return even the closest values, not like the exact ones. So result dot add that thing, right? Result dot add a new int, and the values are gonna be a dot get of that I 0, and we are saving the IDs, not the values itself. J of 0. Okay, and int index equals to j minus 1, and while the index is greater than equal to 0, and b dot get of that index 1 equals to b dot get index plus 1 of 1 result dot add new int a dot get of I 0 and b dot get of j of 0. That would be it. Okay, and in the end, where this is where this if is finished, we're gonna say that we need to increment the I. What is happening here is that okay, you added the result, right? But now the index is j minus 1. Remember when we were talking about that what happens if okay, we found the answer here where I was here and the j was here, right? So now we found the answer, right? But in this case, what if we have duplicates, right? If we have duplicates, and what if we, so that's the thing we are covering here, that okay, you found the answer, that's nice, but start from the index. As long as the index is greater than that, and this is equal to, and like b's value is not changing. So what if 1 has also a value of 3? So as long as that is the case, we're gonna keep adding the next one to that one. No, this should be, yeah, that's what I was wondering, that the B should be the index, and we need to decrement that every single time. Yes, because we're gonna keep looking at the index, and this is just to cover the duplicates. Yeah, and once we are out of here, this while loop, we can return the result. We already talked about the complexity here. So if we have n number of elements with the IDs and those ones, we are actually the time complexity is going to be O n log of n, because we are sorting them. Uh, yeah. In terms of the space complexity, I will call it, worst case would be O of n, where we have to we have to save all of them, like all the n number of elements into the result. So the just because of the result, I'm saying uh, we need linear space complexity. That's all I wanted to cover. Thanks for watching.